Morning, everyone. How's everyone doing? Well, thanks for being here, firstly, and I'll try to make it short because I think I'm standing between, the break. My talk is before the break, so I'll try to make it quick. But, I want to start with something bold, right? I want to say batteries can always catch fire, right? And I want to see hands raised on how many people agree with this statement. Okay, great. I see we've got a good mix of optimistic and pessimistic audience, but that's a great mix because we always need a debate. And I will share my opinion on this later on in the slides. So I think the leaders here, Mr. Anand, Dr. Raja, have said it enough. We are going towards an energy mix. That's going to be our future. And for India, what makes sense today is low carbon fuels, hydrogen fuel cells, and also electric vehicles. Now the challenge in front of us is looking at 2020, the market penetration for all of these was about 1%, right? And as India, we always like leapfrogging, right? I mean, BS4 to BS6, and we've set a target that's really aggressive, right? We want to be, we want to be at 30% adoption. This is only for electric vehicles, and that lays a lot of challenges. And I think all of the speakers before me laid out those challenges. And it's a problem with a lot of constraints. We have to do that in the right way, so that we become energy independent, as Dr. Raja was saying, and we have to develop and manufacture things indigenously. We don't want to be an importer of technology. We want to develop it indigenously, right? So that poses a lot of challenges, even other challenges such as infrastructure. Will we have the supply chain ready? Will we have the materials to supply? So it's not just an engineering problem. It's a very big problem to solve. And there are many speakers here who you will have access to ask these questions. I'm going to focus on the engineering side and what are my thoughts on how we can solve the engineering problem at hand. So a very good morning. So again, I'm Ramnik. So I'm going to be talking about the engineering challenges towards India EV global leadership. We want to take a leapfrog not just in technology, but going ahead of the world in the technology and making sure we become a global supplier of technology for electric vehicles. That's our mission, right? I think this is something to what was mentioned earlier. Let's go back 5 years. We all thought electric vehicles are going to be easy, right? Why? Because it was said that it had 2 orders of magnitude less moving parts than its ICE counterparts. Great, it's going to be easy. We're going to put it together. It's going to be great. Now, what we've realized we have less number of parts that are moving for sure, but these parts are very closely connected to each other. They need to talk to each other very closely and make sure they assist each other. Else, things can go wrong, obviously. On top of that, everything that is stitched together, if you look at passenger vehicles or even some of the heavy-duty vehicles, thermal system is going to be a key part that's going to connect everything, right? And what I want to show you in this image is if you count the number of controllers, that would be the green boxes. If you look at the number of controllers, just in the thermal system here, we've got 7 control points that are controlling all of these different circuits, right? So you can imagine the complexity in making sure all of these components talk to each other to make sure you get the best efficiency, and you also get the most safe vehicle out there. So that's why it adds to the complexity. And of course, while doing all of that, you also have to make sure that your components are well engineered and they talk to the system well. You don't want your motor to get heated and demagnetized. You don't want your vehicle to stop while on a hill. Your batteries to go into thermal runaway. At the same time, making sure the battery spare of temperature is within a certain limit so that they age equally, right? So there's no warranty risks. And there are bigger trade-offs, right? If you talk about trade-offs such as how do I make sure my passenger is comfortable, right? So human comfort is going to be critical. Why? Because every ounce of energy in an electric vehicle has to be optimized. So how can I optimize human comfort at the same time make sure that my battery is safe, same time make sure that my motor is safe? So that's what add to the complexity, the interrelationship and the dependencies, right? So here I want to answer the question, or the statement that I made. Batteries can catch fire only if they're not engineered well. We have an opportunity here. I think we can make sure that the batteries are made in a way that it do not go into thermal runaway scenarios. And of course, simulations can play a role there. I think we've had a challenge from Mr. Anand today to create electrothermal models that can predict such technologies, and I can say that we are working on it, and we'll definitely take that up as a challenge, right? So in summary, what are the the engineering risks today, right? I mean, of course, we can have cell fire, thermal runaway, battery aging, range loss. These are all things that can cause monetary losses, warranty losses. But the bigger thing is damage to the company's reputation, which is, I would say, much more costlier to reverse than anything else, right? So how do we do it? Now, here are some points that I highlighted. How can we make sure these engineering risks are mitigated early? Now, these points were brought up earlier. System level interactions, I think both the speakers mentioned that. One of the things that Dr. Raja mentioned was transients. A lot of the failures happen during transient modes, right? That's something that we ought to pay a lot of attention to, not just worst case scenarios that we used to look at in our past life. And then of course, all conditions, elevation, temperature, drivability, driver characteristics. We all know how our cars are abused, right? Of course, a truck for a particular weight is never used for that weight. It's maybe used for twice of that weight, right? So all conditions have to be considered as well. So I would say bringing all of that together, I wanted to put some EV-related challenges that we have been focused on and making sure that our products reflect that going forward, right? The first thing is that, as I mentioned, systems are tightly coupled. So we should provide a solution that helps people couple these systems and create collaboration. One of the things that was highlighted was the continuous cycle of development, right? So how do you get the most latest information? So if your battery engineer is working on a different concept, how does the vehicle guy get to know? That's a bigger challenge. So how do we increase collaboration automatically while ensuring that the simulation models are automatically updated across the ecosystem? So these are some of the challenges that we have taken up, right? There are, of course, reskilling challenges. I think, as mentioned earlier as well, we are all from a different expertise, either electrical engineer, mechanical engineer, but now all of us have to collectively ensure that, we are a cross-domain engineer. A mechanical engineer is supposed to work with the BMS and, with the electrochemistry side of things, and that's really important. That's where I think reskilling, as, all of us in India, is a challenge that we are trying to address as well. And last but not the least, retooling. It's a big investment, right? I mean, if you're trying to launch a new electric vehicle, with the manufacturing retooling to the engineering retooling, that's a big cost, and you have to make sure it's optimal, right? So you want to select tools that are powertrain agnostic, processes that are powertrain agnostic, because going back to the title, the new energy is going to be a mix. They're not going to be silver bullets as we think, right? So you want to establish processes and technologies that are going to be adoptable to all of these powertrain technologies, right? So how are we creating our tools? What's our vision behind, right? So given the complexity in electric vehicles, there are a lot of questions that can be very simply answered, and there are questions that need a very high fidelity model, right? And you need to choose for each problem, how do you get the right fidelity? Now, what would be great is if there's, if there's something that can span the range of these, fidelities and make sure that, between teams, there are no exchanges out of your system that is defined. So what if, you could do your system level analysis for, your target setting, etc., while at the same model, you could integrate your balance of plant model for a fuel cell and engineer, things like, even detailed things like, how does your injector work for humidification of the hydrogen circuit, right? So you're going from a very high level to a very detailed level within the same model. And of course, you can also then start looking at component level design, where you're looking at a fuel cell stack and you're looking at the temperature distribution inside the fuel cell stack. How can you design your cooling system to make sure it's managed throughout the stack, right? We've all seen the V-cycle, but for electric vehicle, as it was mentioned, it's a cyclic process, it's an iterative process, more than ever before, because each of the components are very much dependent on the other. So what we have been doing is identifying these iterations. These are all new things that the industry was taking up. For example, here, the vehicle team might come up with system level requirements. The component teams, the battery, motor, or the sunrise components, as was said earlier, will give you the subsystem level performance, and that needs to be fed into your system level models to reanalyze. Once your partner is on board, you get more data, you put that in. That has to be reiterated, right? So we've identified such iterative processes for all of these components, right? And that's something that we are creating as a process. For example, a battery or a cell engineer is worried about the electrode design, is worried about the cell design, if they're doing it on their own, or even procuring material selection, pack design, all of that, right? And it's going to keep iterating over it. But what if he had a vehicle that could give him the right loads over transient cycles whenever he needed it, right? So now if there is a possibility of a single platform that connects these two, and a process, an engineering process and mentality that encourages it, there can be a lot of virtual validation and surprises eliminated earlier. Envision if you have an electrothermal chemical battery model. I know that's a lot of words, but that's the need of the hour. If you had that integrated to your vehicle model that can see the real loads of the road, you can actually calculate what is the most important thing, it's the life of the electric vehicle, right? You can do sensitivity analysis to temperature, charge, drive patterns, duty cycles, all of that, and look at what the worst case is, so you can have a confidence on your warranties, right? So this is something that we have been working towards quite a bit. Now, as I said, these iterative processes are there for everything. You talk about batteries, motors, power electronics, right? I mean, that's another iteration with your vehicle specifications. So we have been working on creating these processes which will make these exchanges between the teams efficient and flawless, right? So that's been our overachieving goal. Now, this also requires reskilling, right? Because when you're exchanging this information, you need to understand what you're talking about, right? I mean, I just want to highlight a piece of history here. I mean, we opened our India office in Pune in 2018, and the sole mission was to work with Indian OEMs even closely, like what we were doing before. Of course, we started our journey with India, long back, early 2000, but since then we've had the privilege of taking these processes and working with a lot of the OEMs, and we're really appreciative of that, to give us an opportunity to develop these processes and also implement them, in a very rewarding fashion. There have been OEMs, partners, and also academia that has helped us learn these processes in an Indian standpoint, and then also implement them in collaboration. So I really thank everyone in this room who has collaborated with us and our future partners as well. With that, I'll come to the last problem, right? Retooling. Now, tool has to be powertrain agnostic. That has been one of the goals since we started the company in 1994. It has to be a full vehicle modeling platform and agnostic of the technology. And I think today we are there, right? I mean, we can model fuel cells, electric vehicles, and a lot of things. That's a need of the hour. The other challenge with retooling is access to technology, right? I mean, with startups. I mean, I have to mention this because we are in the city of startups, right? Bangalore. Today we have 470 startups in the electrification, in the domain, and we want to make sure that the technology is accessible to them. So it gives me immense pleasure to announce, a startup package, I would say, or a startup program where we are onboarding startups, and with that we are helping them to, to get access to the tools that are required for system engineering, everything that we discussed today, and also we are assisting them in adopting the model-based system engineering mentality early on into their engineering process. So that's, of course, we are very excited for this, and we welcome each and every one of you, if you are in a startup, to approach us and see how we can collaborate. So on that high note, I want to quickly wrap up and say thank you for your attention, and I look forward to this great day, a lot of exciting discussions and interacting with all of you today. Thank you.